an angle bisector, then it would be equidistant to the sides. So from here to B would be the same as from here to A. Okay? And then the converse of that's the next theorem. Any point that's equidistant from the sides is on the angle bisector. Okay? So keep in mind those theorems here. And then the last thing we had about the incenter, okay, the incenter is equidistant from each side of a triangle. So from the incenter to each side is the same distance. This would be the same distance as that, is the same distance as that. Okay, KP, KQ, and KR. Again, all on your postulate sheet. Those are the first 5 or 6 there. Okay. And we know the incenter is the point of concurrency, is where the angle bisectors meet. Now the new one, okay, is a median. So this would be the next one that could show up on a vocab quiz. I know right now it's a lot of definitions. Later on we'll do more problems. I hate giving this many definitions and that sort of thing, but this chapter is filled with them. So that's why I broke it up into 2. But a median is a segment that goes from the vertex of a triangle to the midpoint of the side that's opposite. That's all it does. It goes from the vertex to the midpoint of the opposite side. Okay? So in that case, it's hard to see with that projector not working right, but it would be here, and these 2 segments would be the same. From the vertex to the opposite side. Okay? At midpoint. Now that's different from a perpendicular bisector in what way? In this case, it looks like it's probably the same. So that's kind of a bad example. But why does this differ from a perpendicular bisector? Because they both go to the opposite side and cut it in half. In a median, it doesn't have to be at 90 degrees. And a median, it always goes from the vertex. Those 2 things don't have to be true in a perpendicular bisector. Okay. So what I'm going to do is I only got a few pair of scissors, so we're going to try this here. Point that you have is called the centroid. Okay. This point where the medians meet is called the centroid. So the centroid is where the 3 medians of a triangle meet, also called the point of concurrency for the medians. Okay, the centroid is where the 3 medians of a triangle meet. Okay, that would be the next vocabulary. So notice each of these special line segments, we call them something, and then where they all meet, we call that something else. So if I said the centroid of this triangle is point A or whatever, you would know I'm talking about the medians of that triangle. Okay. So the centroid is the point where the medians meet, so it's the point of concurrency for the medians. So another special property about a centroid, okay, and I'm not sure, you'll have to check if this is on your postulate sheet. I know it's a theorem, but I'm not 100% sure if it's on there. But what this theorem says is the centroid of a triangle, the centroid of a triangle is exactly 2/3. It's exactly 2/3 of the distance from the vertex to the midpoint of the opposite side. So what that means, like for example, let's just look at this median AE. That's a median, okay? From A to L, from the vertex to the centroid, is equal to 2/3 of the whole thing, which means LE is 1/3 of it, right? So for example, if this was 2, this would be 1, right? Because the whole thing would be 3, and from here to here is 2/3 of it. From the vertex to the centroid is 2/3, okay? So the way you write that equation is from the vertex to the centroid, so in this case AL is equal to 2/3 of the whole thing, or LE is equal to 1/3 of the whole thing. Okay. So let's look at a problem here in just a second. They divide each of the sides in half. We know that. Let's come to the altitudes first. I mixed it up here. The altitudes. This is the last type. Last type is what we call an altitude. It's a perpendicular segment, so it meets at 90 degrees, but it goes from the vertex to the opposite side or to the line that would contain the opposite side. So I need to darken these up here a little bit. For example, that is an altitude because it goes from the vertex to the opposite side at 90 degrees. This is the last one here, the altitude. In this case, to go from the vertex to the opposite side there's no way you could go from the vertex to the opposite side here and meet it at 90 degrees. So if that's the case, you go from the vertex to this line extended at 90 degrees. So it's kind of like a dot there, there. Okay. Same here, go from the vertex to the opposite side at 90 degrees. Okay. Vertex to the opposite side here. You draw it to the other side like if it was extended. So most people put a dash through there or something like that. Okay. But yeah, so it doesn't always go through that triangle. Okay. And then of course that has a name, that point of concurrency where those three meet. This is the last one that would be on that vocab quiz, which is called orthocenter. Okay. It's orthocenter. That's the point of concurrency for the altitudes. The point of concurrency for the altitudes is called the orthocenter. Okay. So there are your 8 terms for this section that could be on that vocab quiz. And you need to know orthocenters paired with altitude. You need to know end-centers paired with median, that sort of thing. Okay. So this is the last one. Okay. Thanks, AJ. All right, so don't be confused by this as decimals here. I wish I should have changed that. But it's not decimals. So it says these 3 points, U, V, and W, are midpoints of each of those sides. So I don't tell you if this is a perpendicular bisector or a segment bisector or an angle bisector or median. I don't tell you what those are. But just from this statement, you should be able to determine what these segments are. What are they? Angle bisectors, perpendicular bisectors, medians. They go from the vertex to the opposite side and cut it in half, so that is a median, right? A median goes from the vertex to the opposite side, cuts in half. So we need to find A, B, and C here. Okay. So let's take it one step at a time. Let's look at this one here. Okay. Yeah, that's fine. Thank you. So the theorem we have, the centroid theorem, says if you go from the vertex to the centroid, that's 2/3 of the entire median. So from the vertex to the centroid, in this case, is 3b plus 2. Okay? From the vertex to the centroid is 3b plus 2, right? That's equal to this entire median, xu, which xu is 3b plus 2 plus 8.7. But it's 2/3 of that. Everybody with me how we got that? Okay. 2/3, this entire segment, this is ux, right? Ux is 3b plus 2 plus 8.7, right? The median is that entire thing. And the centroid theorem says if you go from the vertex to the centroid, that's equal to 2/3 of the entire median. So we would have to work out this algebra problem to find out what B is. We would combine like terms here, distribute our 2/3, go from there. So let's go ahead and do that. So we have like terms in here we can combine. We're going to make this 3b plus 2 is equal to 3b plus 10.7 times 2/3. Again, this is the entire median. I know from the vertex to the centroid it's 2/3 of that. Okay. So when I multiply this by 2/3, I distribute that 2/3 is equal to 2b when you take 3 times 2/3. Okay. And then plus, so we'll round that off to 7.1. And then we just solve our algebra problem from here. We'll move this 2b over to the other side by subtracting it. We get 1b. We move this to the other side by subtracting it. So we would get b is equal to about 5.1. Right? Okay, we subtracted that over, we subtracted the 2 over. So from the vertex to the median, it's equal to 2/3 of the entire thing. So let's look at another one. Let's say this one. Okay. So we know from the vertex to the centroid, so that's 7.4, is equal to 2/3 of the entire median. So the entire median in this case is 7.4 plus 2a, right? 7.4 plus 2a. That's the entire median. It was 7.4 plus 2. So then I just work out this algebra problem. Okay? 7.4 equals, can somebody knock that out on their calculator? So we move that 4.9 to the other side. Okay. We're going to be left with 4/3 A on that side. Cut that off there. Remember, to undo multiplication by fraction, we just multiply both sides by that reciprocal. You take times 3/4 and times 3/4. So when you take 5.5 times 3/4, what I did was I changed 5.5 to 11/2, right? Then multiplied them. You can leave it as an improper fraction or a decimal if you want. Okay. So that's A, that's B. You try and find C here now. In this case, with there. Yes, question.
On the first one we did,
Uh-huh.
the last one, how did you get 2b plus 7.4?
I distributed this 2/3 here.
Oh.
So I took 2/3 times that and times that. So I took it times 3b, I got 2b, I took it times that, I got that. Yep. So try and find C here then, doing the same thing. But you got to think which side. You got to go from the vertex to the centroid is equal to 2/3 of the whole thing. So I'll give you a minute to try that. So if you didn't have a calculator handy, it's going to be a little difficult. Because like I said, this is with decimals in here. I hope that's not confusing many of us. But okay, so to find C now, we want to go from the vertex to the centroid is equal to 2/3 of the whole thing. So the vertex in this median is Z, right? That's where the two lines meet. So from C to the centroid is equal to 2/3 of the whole thing. So I'm going to say 15.2 is equal to 2/3 of the entire median. And the entire median in this case is those two pieces added together, those two chunks. So that's 5C plus 15.2. Because I just add those two chunks together. 2/3 of that entire median. So to solve that, I'm going to distribute the 2/3. So I have 15.2 equals, that'll be 10/3 C. And then 15.2 times 2/3. Then I'll move that 10.1 to the other side by subtracting it. So I'm left with 5.1 equals 10/3 C. So then to solve this, I'm going to multiply both sides by the reciprocal to get C by itself. So multiply by 3/10 here, by 3/10 here. That's going to be like 15.3 divided by 10. It's going to be like 1.53. Is that what we got? All right, so C itself is 1.53, which now means you could find each of these pieces. If I plug in 1.53 here and multiply that by 5, that's from here to the centroid. So this can give us a lot of information just by knowing we have some medians here. Okay. Of course, those postulates are important to know. In addition to this chart, which is on, I think, page 274 in your book. Now, what type of lines they are, that will not show up on a quiz necessarily or even homework. Okay, that's a good thing to know. This chart's on there. But what you definitely need to know is that a perpendicular bisector, its point of concurrency is a circumcenter. An angle bisector, point of concurrency is the incenter. Now, I don't know, I haven't had anybody do this. I kind of challenged last year to make like an acronym or something, you know, or aren't those things called acronyms? I don't really even know.
Sure.
You know what I'm talking about?
Yeah.
That if you did like P, A, in this case M and A, and then C, I, and C, O, well, that's kind of easy. Okay.
Yeah, you see what you did there.
That if somebody wants to think of a creative saying, you know, I'll listen.
Yeah.